Hi everyone, in this tutorial I'm going to go over physics practice exam number 3 which you will take on Friday. The test I'm going to give you Friday is going to be similar to this one. Please do not memorize, please study. If you do memorize, you will not get 100. If you study, you will get 100. So I highly encourage you to take this test tonight, grade it, tomorrow night, grade it, and on Thursday, and also grade it. And then finally, when you take it on Friday at tech, you should get 100. Good luck. In this tutorial, I'm going to go over physics practice exam 3. I'll give you physics exam 3 on this Friday. The exam that I'll give you on Friday would be similar to this one. All right. I posted this one to the Google Classroom on last Friday. Right. So let's go over the exam. Okay, this is the problem number 1. I have two men. Mr. Body moves with constant velocity from one edge to other edge to the east direction. Mr. Terry also moved with constant velocity from one edge to other edge, but he lost control. So he falls and he hit the ground. So you're going to have to find Mr. Terry's impact velocity. Okay, so let's put both men over here. Before I go over the problem, let me study the equation. D is equal to VAT plus half AT square, right? This is vector, this is vector, this is also vector. There are 4 quantities over here. 3 of them are vector and only one of them is scalar. Okay, from this you can get x direction and y direction. So let's write the x direction one. X direction one would be dx is equal to vix t plus half ax t squared. Okay, now I decided not to put any subscript under t is because t is a scalar quantity. Okay, now let's write the equation for the y direction. Dy is equal to viyt plus half ayt squared. Ay has a name. Ay is lowercase g, and lowercase g has a size -10 meter per second squared. Good. Okay, now let's find Mr. Body's velocity from this edge to this edge. Okay, so I'm going to use this equation, right? This equation going to allow to find Mr. Body's velocity. Mr. Body moved 20 meters, so I'm going to replace this one by 20. Mr. Body's velocity, that's what we are trying to find. Mr. Body spends 2 seconds plus half. Ax is 0, acceleration due to gravity is 0 as long as you do not lose contact. Mr. Body never lost contact with the rooftop and t squared. So his velocity is 20 over 2, which is 10 meters per second. So velocity is Mr. Body's velocity when over here or anywhere, velocity is constant. So Mr. Body's velocity is 10 meters per second. Excellent. Now we're going to find Mr. Terry's velocity. I'm going to put the equation back exactly where it was. Now I'm going to find Mr. Terry's velocity. Mr. Terry's velocity, Mr. Terry lost contact over here, okay, and he started falling. We want to find his velocity. So it has to be 2 steps. Okay, step number 1, we're going to have to find the time, and step number 2, we're going to have to find the velocity. Bf is equal to vi plus at. So it's a 2-step problem. dy, we know the dy, -20, okay, and we know the viy, okay, nobody pushing. Mr. Terry drove himself, so Mr. Terry's initial velocity at the y direction is 0. Plus half ay has a size. Ay is -10. Okay, ay has a size, so it's -10, and then of course t squared. Now, as you see, this is -20 is equal to -5 t squared. You divide both sides by -5, you get t squared is equal to 4. So t is equal to 2. Okay, so Mr. Terry's velocity, impact velocity would be vi is 0, -10, this is 0, -10 times 2. So his impact velocity would be, of course, -20 meters per second. Okay, now I'm going to ask you to draw the graph for Mr. Bari and Mr. Teddy. So the graph for Mr. Bari and Mr. Teddy, Mr. Bari's journey is from here to here. Okay, so I'm going to draw the graph from here to there, Mr. Bari. So 1, 2, 3, 4, 5, and 6. This is Mr. Bari. So this is displacement versus time. This is velocity versus time. This is acceleration versus time. This is distance versus time. This is speed versus time. This is absolute value of acceleration versus time. And of course, this is time. Okay. All right. So I'm going to do it for Mr. Bari. Mr. Bari, again, I said Mr. Bari's path. Mr. Bari moved from here to here. Okay. So his displacement would be, and he was moving to the east. Don't forget that. Okay. He was moving to the east. Okay, now I'm going to do it for Mr. Terry. Mr. Terry, I'm going to do it for Mr. Terry. 1, 2, 3, 4, 5, and 6. This is displacement. This is velocity. This is acceleration. This is distance. This is speed, and this is acceleration due to gravity. Okay, now for Mr. Terry, for simplicity, I'm just gonna do this one. Okay, just this one. That's it. Mr. Terry, when Mr. Terry was in free fall. That's all I'm gonna do. When Mr. Terry was in free fall. Okay, so here's how it's gonna go. Okay, so that's it. Now we're gonna do problem number 2. Problem number 2 is Mr. Bari on a bike trip. Problem 2, Mr. Bari is on a bike trip. Okay, so Mr. Bari is on a bike trip. Okay. All right, and the T1 is 0 and T final is 2 hour. So Mr. Bari is on 2 hour long bike trip, and in 20 mile, D1 is 20. Let's say D2. Let's call it D2. D2 is 20 mile. We're gonna find T2 in a second. He saw his speed limit 25 mile per hour, right? Okay. All right. So we're gonna solve this problem. What are we gonna do? We're gonna find D1. We're gonna find V1. We're gonna find A. We're gonna find V2. We're gonna find A. We're gonna find D2. We're gonna find V2. Not V2. D3. D final, V final, and A. Okay. All right. D final is same easy, very easy. You use the position function. Position function for Mr. Bari is 15t squared. Okay. So you are using the time. What is the time? 2. At 2, you want to find at 2 hour how much did he move? He's spending 2 hours. Okay. So 60. 60. I'm not going to write SI unit because it's going to get too crowded. Velocity final, we're going to come back. Acceleration, we're going to come back. We want to find the time over here. So P of t is equal to 15t squared. How are we going to find the time when distance is 20? Well, that's easy. Okay, we're going to divide both sides by 15, 1.15. I'm not going to write SI unit because it's going to get too crowded. Good. That's all I need. Now I'm going to draw dt, vt, and at graph. So now let's do dt, let's do vt, all right, and let's do at graph, right? So the dt would be, this is displacement, this is displacement, this is velocity, and this is acceleration versus time. So the dt would be very easy. The dt would be this, because the object was accelerating, because the velocity is 0 over here, the distance is 0 over here, so and the velocity is not 0 over there. That means the object was accelerating. Velocity is 0 over here, but velocity is definitely not 0 over there, because if you take the slope would not be 0. Okay, good. Now if you the slope of dt graph is the velocity, okay, and the slope of vt graph is the acceleration. Okay, good. Now let's find the velocity. Speaking of velocity, the area under the curve, so what is this green area? We know this green area has a name, and that is displacement. And we also know what is the size of this green. The size of this green is 60, right? So you're gonna write area is half bh. All right, so area is displacement, and half b is time, and h is velocity. So displacement, we know that is 60, half, and the time, we also know the time is 2. Over here the time is 2, so 2 velocity. To cancel velocity is 60. So we know the final velocity is 60. Now we want to find the acceleration a few different ways. So let's find acceleration. One way you can find the acceleration is this way. So this is area under the curve. Let's see. So area under the curve has a name, and that is called velocity. So the velocity is 60. Velocity is 60. Velocity is 60. Okay, so now the area is BH. All right. So area under the curve has a name, velocity. B is t, and h is acceleration. So the velocity is 60, and time is of course 2, and a is a. So acceleration is 60 over 2. So acceleration is 30. All right, now we're gonna find the acceleration different way. Okay, so let's say acceleration is v final minus v initial over t final minus t initial. So acceleration v final is 60, v initial is 0, t final is 2, and t initial is 0. So this also going to give you 30. You're going to find the acceleration few different way. We're going to find acceleration is this way. Acceleration is, let's say, d is equal to vit plus half at squared. So you're going to find d is, of course, we know that d is 60, vit is 0, plus half a, and this is 4. So 2 goes to 4, 2. So 60 is equal to 2a, a is equal to 30. Okay. We also can find the acceleration another way. Vf squared is equal to Vf squared is equal to Vi squared plus 280. So Vf squared is, let's say, 60 squared, so 3600, 0 plus 2 acceleration, and distance is, of course, 60. So you have 0, 0 cancel. You have 360 is equal to 12a. So a is 360 over 12. So 12 goes to 36 3 times, so it's 30. Okay, good. Now, how can we find the velocity over here? Well, it's very simple. The velocity over here is, although I'm probably never going to ask you to find the velocity over there, but okay, so you can find the velocity over there by, say, you can choose a point right here. Okay, so let's say this is the time is 1.5, so this is, let's say, t is equal to 1, right? So then if t is equal to 1, then what is the d1? d1 would be equal to 15, right? Okay, so you have the t1 is equal to 1, d1 is equal to 15, t2 is equal to 1.15, and d2 is equal to 20. So then you can find the slope. All right, the slope would be the velocity, right? So m is y2 minus y1, x2 minus x1. So m is y2 is d2 minus d1, t2 minus t1. So d2 would be what? 20 minus 15, and 1.15 minus 1. So you have 5 over 0.15, right? and 1.15 minus 1, and that is 0.15. So you have 5 divided by 0.15, and that is 33. So the velocity over here is 33 mile per hour, and that does make sense. The velocity increases as he moves to the final point, and the final velocity would be 60, and this is less than 60. That makes sense. Okay, so that was problem number 2. Body is moving from Oxford to Cambridge. This is east. With the velocity is 20 mile per hour, and then Cambridge to Oxford. He immediately returned from Cambridge to Oxford with 30 mile per hour. Okay, so we need to draw first graph, and then from the graph we're gonna do some point. So let's do 6 graph. Graph number 1, graph number 2, graph number 3, graph number 4, graph number 5, and graph number 6. We're going to call displacement versus time, and we're going to call velocity versus time. We're going to call acceleration versus time. We're going to call dt. We're going to call st. We're going to call acceleration t. And of course, everything has to come with t, because t is always the x-axis. So let's do the first one. The first one, Mr. Bari is moving to the east, right? Okay, with constant velocity. So moving to the east with constant velocity would be look like this, and moving to the west with the higher velocity, moving to the west, and he stops moving to the west with the higher velocity. Okay, good. And that's the approximately graph for what's going on. Okay, the velocity. Mr. Bari moves to the east, right? And then he stops. His velocity is 0, and he moved to the west, and the acceleration would be 0, right? Okay, and the distance versus, okay, so uh, the the absolute value of this one would be the same, and then he stopped, and absolute value of this one would be like that one. Okay, good. The speed would be like this. Okay, and then acceleration would be the same. So here I have the 0, right? So at 0, how much distance he moved? At 0, he moved the 0 distance. At 5, okay, at 5 hour, because the v1 would be how much? So the t1 would be v1 over the d1 over v1, d1 over v1. So the d1 is 60 mile. All right, so the d1 is 60 over 20 would be 3. So t1 would be 3, and t2 would be 60 divided by 30. So t2 would be 2. So total 5 hours. So, okay, so this is 3 and this is 5. This is 3 and this is 5. Okay, this is 3 and this is 5. This is 3 and this is 5. Okay, good. So at when the distance is 0, right? When the time is 0, because this is time. When the time is 0, distance is 0. When the time is 5, okay, how much did he cover? 120. When velocity is 0, when the time is 0, the velocity is 20. Okay, when the time is 5 hour, velocity is 30. When the time is 0, distance is 0. When the time is 3 hour, velocity distance is 60. When the time is 5, distance is 120. When the speed is 0, velocity is 20. When the speed is 5, velocity is 30. Okay, so this is problem number 3. Problem number 4. This is free fall. This is free fall, and an object is falling from height h. An object is falling from height h. And what type of free fall? This is dropping, and that's how it is, dropping type of free fall. Free fall doesn't mean dropping, but in this case it is dropping. So initial velocity has to be 0 for all 3 cases. All right. So the displacement, how much an object fall in 0 second, 0. How much object how much object fall 0 second. So what would be the object velocity? 0, speed is 0, acceleration due to gravity -10. Okay, and then all right, so at the end of 1 second, how much does the object fall? So let's use that equation. Equation is d is equal to vat plus half at square, right? So in this case, d would be we want to find the displacement at the end of 1 second. At the end of 1 second, the displacement would be, all right, displacement would be this is 0. Why this is 0? Is free fall, dropping. So this is half. Acceleration would be, of course, a -10, and that 1 is square. So displacement would be a -5. So this is -5. At the end of 1 second, at the end of 1 second, displacement would be -5, and distance would be 5. Velocity would be -10. How velocity gonna be -10? Well, Vf is equal to Vi plus At, right? Vf, all right, at the end of 1 second, velocity would be, this is 0, minus 10. At the end of 1 second, velocity gonna be what? -10. At the end of 1 second, velocity gonna be -10. Speed is 10, and acceleration is, of course, the same thing. Okay, now what would that be when displacement is -20? What would be the time? Well, again, we're going to use this equation, vat plus half at square. When it is free fall, dropping, and then bit is 0, so you have half at squared is equal to d, right? Now the displacement is 20. We want to find the time when the displacement is -20, right? So let's isolate time because we want to find the time. 2d over a, right? So 2 times distance is -20, so 2 times -20 over acceleration is -10. So t squared is equal to, you have 40 divided by 10 is 4, so t is 2. So time is 2 when displacement is -20. Distance is 20. This is -20. This is 10, and this is -10. So let's draw the graph. At least draw the 3 graph because I'm getting a little tired. Draw 3 graph. Distance, displacement versus time, velocity versus time, and acceleration versus time. So 3 graph would be okay, that's it. All right. So what is this one? This one is d is equal to half at squared. What is this one? This one, v is equal to at. What is this one? Acceleration is g is equal to v is equal to at. And what is this one? Acceleration is g. Okay, so that's it. Now we're going to do problem number 5. 20 meters per second. So initial velocity is 20 meters per second. Okay, this is my dt graph, right? So this is my problem. The problem is, this is my y-axis and this is my x-axis. Y and x, d and t. Okay, good. Initial velocity is 20, 20, 20. Okay, the velocity at 0 second, okay, we're gonna have to find at 0 second displacement. Object displacement is 0, distance is 0, velocity is, of course, 20, right? Even at 0 second, object velocity is 20, 20, -10. Okay, let's do the next one. Time. When object velocity is 0, object velocity is 0 over here. When object velocity is 0, what is the time? So we are talking about when object velocity is 0, what is the time over here? Okay, that's pretty easy. We have to find to find that, we have to find the, let's find the time over here. Is that's even easier. Vf is equal to -20 meters per second. So Vf is equal to Vi plus At. So Vf is -20, Vi is 20 minus 10t. So you have -40 is equal to -10t. So t is equal to 4. So t is equal to 4. If the t is equal to 4 over here, right? T is equal to 4 over here. Velocity is negative 20, and t is 4 over here. If t is equal to 4 over here, then t must be 2 over there. Okay. So the time 2 at 2 displacement. What would be the displacement when the time is 2? The displacement would be the time is 2, so we are talking about this displacement, everybody. We are talking about this displacement. Okay, so find out this displacement. Displacement is VIT plus half AT squared. Of course, we can also find that is VF squared. VF squared is equal to VI squared plus 2AD. The both way you can find it. So the displacement is VIT, which is 20, and T is 2. This is negative 5, 4, which is D is equal to 40 minus 20. So displacement is 20. Okay, so displacement is 20. Let's see whether we get the same thing over here. So the VF is 0, VI is 400 plus 2, this is negative 10, and that's how we're going to find the displacement. So displacement is 400 over 20, so 20. Okay, good. Displacement is 20. Okay, good. What about the distance? The distance is 20. Okay, if displacement is 20, distance has to be 20. Speed, okay, velocity is 0, so speed is 0. Acceleration is negative 10. Okay, the last one, velocity is 20. When the velocity is negative 20, we already found the time. Time is 4. Time is 4. Okay. Displacement. Okay, so let's find the displacement. D is equal to VAT plus half AT squared. We kind of know the displacement. 20 plus 20 is 40. Okay, because if this one is 20, then this one has to be 20. Okay, 20, 20, 40. But let's find out. VIT. VI is 20 times 4 minus 5, 16. So D is equal to okay, so the displacement is, of course, displacement is 0. Okay, all right, displacement is 0 and distance is 40. Okay, because this is 20 and this is 20, so this distance is 40. Speed, all right, let's find the velocity is negative 20, so speed must be just 20, and this is negative 10. Okay, let's draw the graph. DT, VT, and AT. That's it. DT. Okay, so we're gonna quickly draw the graph. This one would be DT, and this one would be VT. All right. So this part is the velocity. Okay. So there is some initial velocity. So this is this, and this is this, and this is this. Okay, and acceleration is of course negative 10. This is the last problem, and what type of problem? This is free fall, and I see the velocity is less than 0. In this case, velocity is 4 meter per second, so this is negative 4 meter per second. So that means is throwing down, right? Why it is throwing down an object? You throw it down. So you just don't drop it, you just don't let it go, you just throw it down like that from the height h, right, with the negative velocity. Okay, that means it's free fall, throwing down. Okay, great. So your initial velocity negative 4, and negative 4. Great. The time, when the displacement is 0, the time must be 0. Of course, distance is 0, velocity is 0, not velocity is 0. Velocity is negative 4, this is 4, and this is negative 10. Okay, now we are talking about when the time is 1. Okay, and the displacement would be negative 9. How? So displacement is equal to VIT plus half AT squared. So the displacement would be VI would be negative 4, and the time would be 1 minus 5, 1 squared. So negative 4, negative 5 is, of course, negative 9. Negative 9. Distance is 9. Velocity is, of course, negative 14. How the velocity is negative 14? VF is equal to VI plus AT. All right, VF is equal to negative 4 minus 10 and then 1, so is a negative 14, and then this is 14 and this is negative 10. Of course, the last one, which is the time when the displacement is 20, what is the time? How can we find it? D is equal to VAT plus half AT squared, right? And then this is 20 and this is negative 4, and then we want to find the time, and this is negative 5, and then T, of course, is squared. Now it seems like we have to do a quadratic, so you have 5t squared, you have plus 4t, you have minus 20. Okay, so let's see whether we can do factoring. Let's see, factoring is now good. So a is 5, let's do it here. A is 5, b is 4, and c is negative 20. So we have minus b plus minus b squared minus 4 AC over 2a. All right, so you have minus 4 plus minus, you have 16 minus 4, a is 5 and c is negative 20. Okay, and then you have 10. So you have negative 4 plus minus, you have 416, 416, and you have 10. So you have two things. 416 is how much? The square root of 416 is square root of 416 would be 20.4. So you have negative 4 plus minus 20.4 divided by 10. So it has a two root, negative 4 plus 20.4 divided by 10, negative 4 minus 20.4 divided by 10. This is no good. So this one, 20.4, so 20.4 minus 4 divided by 10, and that will be 1.64. 1.64. So the time is 1.64. At 1.64, the distance would be 20, and the velocity. So the velocity would be 16.4. So how velocity is VI plus AT. Velocity is VI is negative 4 minus 10, 1.64. So V is negative 4, negative 16.4, right? So the velocity would be negative 20.4. So negative 20.4, and the speed is 20.4, and then this is negative 10. Okay, good. All right. Okay, so now let's draw the graph. dt, vt, and at. So displacement versus time, velocity versus time, acceleration versus time. Okay, now distance versus time is you throwing it down, so you throw it down. Okay, so okay, you throw it down, and you throw it down with negative 4. So you have negative 4. This is negative 4. All right. You throw it down from here. Okay. And the acceleration versus time is just this. Acceleration versus time is this. Now, to find the area under the curve, you have to use this. This is BH, and this is half BH. So the displacement for this one would be BH plus half BH. All right, okay.